Good afternoon, everyone. How are we this afternoon?
Good afternoon, sir. Doing
Afternoon,
good.
sir.
Good afternoon,
Good
sir.
afternoon.
Afternoon, sir.
Huh?
We're okay, sir.
Okay,
Doing
cool.
good, sir.
Nice, 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 nice. Okay, are you ready?
Yes, sir. I'm ready to learn.
Telling you,
Me too, sir.
come, I'm not gonna come up on my phone. Come off and leave me alone. So, are you ready? I tell you, do not answer. Miss Gordon, Miss Donaldson, please do not answer. Are you ready?
There's
Yes, sir.
something
What
wrong
is the
back.
new topic, sir?
Ready for what, sir?
Sir, what's the new topic? I'm ready.
Oh boy, I tell you. Let me see if I can share my screen and see.
Sir,
Yes, please.
I sent something in the WhatsApp group, sir.
Okay, I soon look at it. Share whiteboard. I don't even make this thing really work. Um, you see, I don't even make this thing into work. Let me just check on something here. See, all right, so that piece works right there. All right, give me a minute. All right, so I am actually trying to find the orientation of my device. All right, tonight you're going to write. Not that I don't have anything to send to you, but based on what it is that we're going to be moving into tonight, some matrices, um, before we have a conversation about something, I I want us to be prepared to do some writing. I want you to get into the habit of not thinking that every night I'm going to come and give you pre-recorded or pre-prepared notes. But I really want you to get into the habit of recognizing that sometimes you have to come to class to write. No, this is one such class. I will project some stuff for you, but for now, I want you to be able to write. All right, so we're going to be talking about some matrices. And I want to refresh your memories. Now, you know that I know you guys would have gone through this in what do you call it? CSET math. So I'm just refreshing your memory on matrix addition, matrix subtraction, matrix multiplication. Do we have matrix division? Do we have
Sir, I
matrix
don't
division?
think so.
No, we
No.
don't. No, we don't have matrix division. In order for us to do that, we're going to talk about the inverse of the matrix, right? So when I multiply a matrix by its inverse, it's as if I'm doing a division. So we can't really divide matrices. We can only find the inverses of matrices, and that's what we're going to look at. So you notice I use the word matrices just now, just to let you know that the plural for matrix is matrices. So once I'm speaking about more than one, I'm going to use matrices. When I'm speaking about one, I'll just use matrix. All right. So in looking at our matrices, I want us to just refresh our memories. No biggie about it. Really and truly, no biggie about it. I want us to refresh our memories. All right. So if this thing goes, I think all the information will be lost. All right. So no biggie about it. So if I give you a matrix, and if I say to you A11, if I say to you A11, A12, A21, A22, all right. What type of matrix is that? How would you describe that matrix? Okay.
Sir,
Yeah,
I'm not sure, but would it be a 2 by 2 or 2x2 or something like that?
a 2 by 2 matrix. Thank you. All right. Let me tell you what I get off the bat already. That you guys have a problem with matrices. Straight off the bat, the very first question I asked, and you're not giving me the response that I'm supposed to be getting, suggests that you have an issue with matrices. No, let us have a conversation, because I don't want anybody to freak out on me. Talk to me. Let me know how matrix or matrices have abused you in other courses in CSET math. Talk to me. Let us talk it out.
Sir, honestly, I don't remember anything about matrices. Like if you
Okay.
show me, sir, I'll know that that's the topic, but I just don't remember anything about it.
For me too. I never really have a problem with it at CSEC level, but I don't remember.
You remember it. Okay. Patrick, what's it, Pat?
Yeah, I can look at it and remember a few things, not really much, but yeah, that's all.
Shanti, what you say?
Sir, I don't have a problem with it, but I don't remember.
Okay. Natty B, what you say?
Sir, math is not for me. Not
Say it
for
again?
It is not for me.
You're not familiar?
Not for me. Not for me.
Or when you say not for you, what do you mean?
Sir, it's not for me. Like,
Or you say matrices is not for you?
sir, math is not for me. Not just that.
Oh, so hold on now. So you bright? So poor you tell me no says one topic not for you. You're gonna tell me say the whole of the topic them is not for you, Natty B?
not just the truth. I'm not telling a lie.
No, you alone too bright, man. No, man, they can't do that. So, but they tell me, say, sir, this topic, but you ever tell the whole of my topic them in a lie? No, man, not to be a
But
Christmas
you
tree.
want me to tell a lie, and then when
Oh, not to
something
be.
goes to know and you have to finally see what going on, you're gonna shake it and I say, Jesus Christ. I don't want to tell a no lie.
All right, I hear you. I hear you. But we're gonna get there, though. We're gonna conquer this. You know, we don't pursue things and it defeats us. We are gonna conquer this thing because at the end of the day, you guys are all getting your associate degrees. So this thing not going to defeat us. Kimoli, by the way, you can talk tonight.
Sir, what do you mean?
Okay, no, I mean, I remember last week you were having a challenge. I don't know if your system working up now.
Oh, yes, sir.
Okay. Well, you stay with matrices. Or what has it done to you or not done to you?
So I don't have a problem with it. But I remember every single thing about it.
Okay. So when I was asking the question, I was getting any participation. Hmm? Okay. So that's a 2 by 2 matrix. How we know, sir? It has 2 rows and 2 columns. How many rows it has?
2.
Rows.
And 2 columns. When we're naming our matrices, we name them from the rows first and then columns after. We name them from the rows first and then columns after. So we don't call the columns first and then the rows after. Naming the matrices, rows are horizontal, meaning left to right. Columns are vertical, from top to bottom. All right. So when we're naming our matrices, we name our rows first and then our columns after. I want to ask you a question though. I want to ask you a question. On screen, I have A11, A12, A21, and A supposed to be 22, but it's not showing so clearly. So let me go again. Let me go again. So I'm saying A11, A12, A21, A22. Tell me, what do you think the significance of that 1112 2122 represents? Look at it and tell me what you think it represents.
So the number and the columns of each number, as in the position that it takes.
Explain.
So like the first A11, it's in the first row and the first column, and then A12 is in the first row, second column, and A21 is in the first row, second row, first column, and A22 is in the second row, second column.
Okay. All right. So, okay, Patrine, I see where it is that you're going to get an A for matrices. I want it to turn up. Continue turning up. Very nice. And you are correct. So my A11, A12, A21, A22 is indicating the position of my elements or entry into the matrix. All right? The position of my elements or entry into the matrix. So it is telling me that it is in the first row, first column. It is Hold on, please. Hold on, please. Oh, Cassia responded to you. I just see. All right. So very good. It is the position of the elements or the entries in the matrix. Excellent. Now, when we are naming the matrix, we normally say it's a 2x2 square matrix. Can anyone tell me why we call it a square matrix?
Because everything in the bracket is arranged in a square manner. It's arranged like as a square.
Okay. Anybody else? Correct. Anybody else can want to word it differently? Hmm. All right. Let me just remind you, it's a Friday evening. The tide is turned up on all of us. You don't respond to me, I may fall asleep over my computer. So just answer me, please. Please and thanks.
It has the same number of rows and columns.
Excellent. Okay, so both of you are saying the same thing. I was, however, looking for the same number of rows and columns, right? But the pair of you are saying the same thing. But I was looking for the same number of rows and the same number of columns. Very good. Okay. Now, it's called a square matrix because it has the same number of rows and the same number of columns. So I will say that this is a 2x2 square matrix. What if I gave you this as A11 and A21? How do you name this matrix?
A 2x1.
2x1.
A 2x1, what kind of matrix? So this is a 2x2 square matrix. A 2x2, 2x1 what?
Third column.
Column.
Mm-hmm. All right, the last definition I got. So it has, anybody remember the last definition that the person said to me? I don't remember who it was.
So she said it has the same number of rows and columns.
Mm-hmm.
Oh, so it would be a square because it has the same number of rows and columns as well.
So it would be a rectangle.
Say rectangular.
Rectangular.
Right. Good. Sir, why rectangular? Because the number of rows do not equal to the number of columns. The columns and rows are not equal. So it's rectangular in shape. Can you see that?
Yes, sir.
Yes, sir.
So
Mm-hmm. Name that one, please.
1 by 2
1 by 2.
rectangular matrix.
Is a 1 by 2 rectangular matrix the same as a 2 by 1 rectangular matrix?
No.
No,
No,
also
No, sir.
no, sir.
Why not?
because one have 2 column and one have 1 column and 2.
Somebody may be saying, duh, can't you see that? But I asked the question because it's going to be very important. Very, very, very important. So a 2 by 1 matrix, rectangular matrix, is not the same thing as a 1 by 2 rectangular matrix. Yes, sir. One has 2 rows, the other one has 1 row. One has 2 columns, the other one has just 1 column. Very important. All right. And in the final of this mix up, I'm going to give you is going to be A11, A12, A13, A21, A22, A23, A31, A32, A33. What type of matrix is that?
3 by 3 square.
Mm-hmm. So it's a 3 by 3 square matrix. Why is it called a 3 by 3 square matrix again?
Because the number of rows and columns are equal.
Mm-hmm. Very good. Is there anyone in the class that has not seen these 4 different types of matrices on the screen and understand them? All right. So now, this is very good. And in a nutshell, that is my revision on the naming of matrices. The naming of matrices. That's my little revision on the naming of matrices. Then now, I want to see how quickly I can move through these. So I want you to work with me. All right. So let us look at matrix addition. Let us look at matrix addition. Let us look at matrix addition. When you're adding matrices, we're adding corresponding entries or elements. When we're adding matrices, we're adding corresponding entries or elements. We call them entries. We call them elements. We don't really say number. All right. So we call them entries or we call them elements. Now you know the position of the matrix, of the elements in the matrix. A11, A12, A21, A22. If it is that you're talking about a 2 by 2 matrix, If you're referring to a 3 by 3 matrix, it's going to be A11, A12, A21, A11, A12, A13, A21, A22, A23, A31, A32, A33. And each of those elements has a specific orientation, a specific place in the matrix. Because I cannot take A32 and place it somewhere else and place it with A23. Can you see their positions, that they are very different? One is in the second row, third column, and the other one is in the third row, second column. So you can't say, oh, it's the same thing. So you have to be careful of where it is that you're putting those entries or the elements into the matrix. It's just like you live on an avenue. You can't decide to go into somebody else's house and say, boy, I'm going to spend the night here. No, you have a specific residence on the avenue to go. You can go in there freely. Mark you. You may know the person. I may know the person very well, but there's going to be a mix fit, right? You know your boundaries. You can't go in and the people in the fridge. You can't go in. Yeah, there are boundaries. So I'm saying to you, the elements in the matrix, they have a specific location, and we have to respect that location. We must respect that location. All right. So when we're adding matrices, if I say to you 2, 3, 5, 4, and I'm adding that to 1, 2, 4, 0. When I'm adding those matrices, what is going to happen is specific entries will be added together. Specific entries will be added together. For example, this 2 can only be added to this 1. So why? Because that 2 and that 1 is in the A11 position. So specific entries, oh my goodness, I just had a tongue tie. Specific entries must be added to each other. So I can't add an entry in A11 and A21 position. The A11 must be added to something in A11. And guess what? The subtraction is the same thing. I must look at specific entries. The multiplication is somewhat different. All right, and when we get there, we'll talk about it. So what is going to happen here is that my 2 plus my 1 will give me, let me just write it out. That will be 2 plus 1. And then I'm going to have 3 plus 2. And then I'm going to have 5 plus 4. And then I'm going to have 4 plus 0. And then when I look at it, what is going to happen now is that I'm going to end up with 2 plus 1 is 3. 5 plus 4 is 9. 3 plus 2 is 5. And 4 plus 0 is 4. So that is what the sum of those 2 matrices will yield. Is there any question? Anybody knows to this? Anybody want me to go through this again? This is revision, you know.
Sure.
For what? Yes, please.
As you like oh yeah, 2 by 2. Suppose to say you could add a 2 by 2 and a 2 by 1. The same thing with a float.
Okay. Okay. So Matthew is asking if I'm able to add a 2 by 2 with a 2 by 1. Am I? If no,
No.
why? If yes,
No,
why?
sir. Sir, the
Why?
matrices should be in the same order
Mm-hmm.
when you're adding.
Mm-hmm. Anything else?
No, sir.
Mm-hmm. lost my information just now. Matthew, you heard what was said?
Yes, sir.
Each entry must be added to a corresponding entry. So put it this way. If you're in a group, or you're in a group, and it's Christmas time coming up now, and they're having this pixie exchange. You don't want to buy something for your pixie, and then after that, no, whoever is your pixie, them not give nothing. And please don't tell me, say, sorry, it doesn't matter. Because we know you're going to feel
Not at all.
away. Same way, Satari. Me buy something for you, you may not be my direct pixie, you know, to be somebody else. And you know, one of the things that I never used to like about it, because when in school, you know, me always say, boy, me go treat my pixie right, and my pixie could never ever figure out who is your pixie when I have their names. They are saying you're supposed to do something nice, you buy a pack of duplicates and you drop on them decks, or you put it under them decks, and them don't have a clue from your pixie. And they walk up and down, and I'm sitting right beside them, and I say, wait, the pixie is something. Them do have a clue, says me. So I go all the way out and I do something very nice. No, so when I do something very nice and I buy you, then the days the mechanical pencils were the inting, you know, if you're not using a mechanical pencil, you know, say nothing. And I can save up and go buy a nice mechanical pencil down at a good store, them called Woolworth. I don't even know that store still exists. Anyhow, you know, my time, if you're not going to Woolworth to buy your stationery and supplies, you're not going anywhere. And when they come, you get a little riff-raff something. It's like, what about this? You invest in that. What's the point? The point is, one or two of the entries in the matrix is going to feel away that they were added to another number to get bigger. But I am still the number that I'm at. So when you're doing your addition of matrices, the dimension should be the same. The dimension of the dimension or size, you know, of the matrix should be the same. Must be the same. So thanks, Matthew, for asking, even though I was going to mention of it. But yes, it must be the same. If it is not the same, you can't add it. If it is not the same, oops, sorry, you can't be added to me. All right. Now, what I like about teaching matrices, I use it in real life. I use matrices for real life setting. So when I'm adding a matrix, I'm looking for a partner, boyfriend, girlfriend. I want to make sure that I add somebody who is going to complement me. So if I see somebody who is not interested in school, just interested in beauty, and you know, in school them have a name for them, but every test come, them get 0 or cash 3 so grades, and you up there get the 80s and the 90s, and they're not. I can't see a life with us together, because I'm me alone. I go work, and you go pressure me. Because you're in the beauty something, so you go on this and you go on that, and poor me, I forgot work out, they forgot. No. But when you see somebody now who you and them are competition, you know, because I saw you get your 99, I saw them get 100, and you said, John Ostam, I can't beat you, right? That's the sort of thing the matrix is talking about. We want equality in what it is that we do, right? So matrices is really real life, you know, real life. No, don't get me wrong. Yes, I understand that some people are attracted to opposites, right? You have your good work, but you want a bad man, or a bad girl. You understand? But let us think of it in the positive light that I am making a reference to, or the analogy to. All right. Okay. So each entry must be added to the corresponding entry in the other matrix. Similarly, when I'm doing a subtraction, each matrix will be subtracted from the other matrix. Each matrix will be subtracted from the other matrix. So watch me. If I say to you 2, 3, 5, 4 minus, and I'm not spending a lot of time on this because this is what you're doing 6 here. I'm just refreshing your memory. Now, again, you'd see that this entry and this entry corresponds because they are in the A11 position. All right. Now, you notice, Matthew, again, that the size, the dimension of the matrix, C's, are the same. We're talking about equality here. We can't have a bigger matrix subtracting from a smaller matrix or vice versa. They must be of the same size, same dimension. All right. So we're subtracting corresponding entries. So this is going to be 2 minus 1 is going to be 2. 3 minus 2 is going to be 1. 5 minus 4 is going to be 1. 4 minus 0 is going to be 4. All right. And that's what our matrix is. So we have the addition of a matrix and we have the subtraction of a matrix. So you have the addition and you have the subtraction. Are there any questions? Because as I said before, yes, please.
For the subtraction, you said 2 minus 1 is 2.
I put that there to see if anybody was paying attention. Very good. I put that there to see if you're paying attention. That's very good. So 2 minus 1 is how much?
1.
1.
Okay. So it's on a Petrina alone paying attention. Petrina, going to buy a bag of tigers here. I'm going to Woolworth to buy the tigers for you. And nobody going like you know eat the tigers neither here. Oh.
No, sir, but eat the tigers.
Oh boy. All right. So very good. Excellent. So I am moving from this. I'm just going to do a one question or two, a one question on matrix multiplication, just to refresh your memory. Just to refresh your memory. Just to refresh your memory. A one question on matrix multiplication, just to refresh your memory. So what I'm saying to you, for addition of matrices, we're adding corresponding entries or corresponding elements. We're adding corresponding entries or corresponding elements. For the multiplication, for the subtraction of matrices, we are subtracting corresponding entries or corresponding elements. And again, the dimension of the matrix must be the same in order for you to do this. Right? Must be the same. Are you following me so far?
Yes, sir.
Yes, sir.
Yes, sir.
Not very nice. Not to be. Unmute and come talk to teacher. How is that so far? Okay, so I don't know how you lie so boy, you know, like maths. And you said all right, it's all right. Sure, you're too lie, man. Go and put on your kettle and sip some tea with teacher. No man, you can't do it, man. This you will conquer this. All right. And it go thank you, sweetie. And it goes for anybody else who, you know, feel a little afraid of the mathematics. I don't want you to be afraid of it. If you're afraid of it, you're going to not attack it appropriately, you know. And I understand fully what fear is. Being a victim of a dog bite before, and it's not even a full bite, you know, it's just a graze because maybe faster than the dog. From that happened, wow, some many years ago. Some many years ago, before some of you were even born. I still have a fear for dogs. No, I have dogs of my own, you know, but I'm not afraid of my dogs. But make me ever go somewhere and a dog come out, and it doesn't matter how minuscule the dog is, and him come near me. Oh my goodness. Peristaltic constriction is in the house because I feel like I need to go because I'm just afraid of the dogs. I am just afraid of the dogs. And I said, oh no, he won't bite. Excuse me. He has teeth. Yes, plastic. Come on now. I said, okay, fine. So this is what happens with some people with mathematics. They were hurt mathematically at some point in time. And even though they survived the hurt, for them to go back and face the mathematics again, the hurt keeps coming back. And I'm going to say it to you, just as though I'm speaking to myself with the fear that I have for dogs, even though I have dogs of my own and I pet the dogs of my own and tie them up and beat them and when them get cut, dressed, cut and thing. I just don't like other people's dogs because I don't know what they're capable of. All right. But we're going to conquer this thing. All right. So we looked at matrix addition. We looked at matrix multiplication. All right. So this is what I want you to do for me. Whenever I use this device, and you notice what I'm doing, guys, I am mixing up how it is that I present the class, the lesson to you. And I'm going to tell you why. And it is not attacking any individual because I've told my other group this very thing last night. I was doing some calculus with them. But sir, you change up the way to do the calculation. Yes, because there are many ways to do the calculation. And I want you to be our favorite all the ways. So I'm doing different methods in doing the calculation. Okay, sir. What I don't want people to get accustomed to is that, oh, I can just come to class and lay down on my bed and just watch this man talk on the screen because I never right now, him soon send something. I don't want that attitude. So whether or not I have the notes, you won't know, I may come to you and say, we're going to write this morning or this afternoon or whatever time of day it is. I may say, yes, man. See, sir, I have no notes. You wouldn't know. But I want to get you involved in the process, not passive, but active, right? It's an action word. I want you to be a part of the process. So sometimes, some nights, you have to write. Some nights you have to write. Now, when you're doing things like these, you have an option. You have an option to screenshot the page and write at a later date, or you can write as I go along, just like when you're in a face-to-face class. What I'm trying to do is to get you as close to the face-to-face as we possibly can, though we'll never, online and face-to-face will never ever be the same, but at least we can find ways to bridge the gap. So one of two things, go ahead.
Speaking of face to face, if it's Starbucks, it would be this late for class.
The answer is going to be yes, but I'm not, because I mean, we don't have, it couldn't be earlier. One, because there are students who are coming out of either a bio class or a chemistry class at 5 o'clock or 3 to 5 or some other. I know some students have class from 3 to 5, right? And number two is that the curfew, I understand, is still at 8 o'clock, don't it? Anybody can confirm
Sir,
that?
today it reached 10. Well, day before yesterday.
Or it reached 10 days before yesterday. All right. Well, the truth of the matter is, I won't even be worried about the face-to-face classes now for this class. The face-to-face classes for other classes, but this class in particular will be treated specially because of the lateness of the class. Not that we don't have classes going on the campus at this time, but I won't be worried about this class, because I mean, we're still, the truth of the matter, oh Lord, I'm being recorded, but the truth of the matter is, with the restrictions being somewhat relaxed and Omicron is around the place now, I expect the cases to go up again, and I expect the restrictions to be put in place again. I don't know why the restrictions were lifted for the Christmas season, but the truth is, I wouldn't be worried. I am not even worried if you were to ask me, because at some point in time soon and very soon, I believe that, we're going to go back to the 8 o'clock shutdown. And if we go to 8 o'clock shutdown, we can't leave school at 8 o'clock because we have to get home. So we'd have to go leave school no later than 7 o'clock. And that is when it robs us of 1.5 hours out of our class schedule. So that's what I'm saying. I'm not saying that we're not going to go, that's above my pay grade. But I'm saying this class in particular, I would not be worried about it. I will not be worried about this class in particular. All right. Your other classes, yes, because you're day students, right? But this class in particular is a specially arranged class because your day cannot take anything else. So I had to put this class at this time. And I don't think I had verbalized my gratitude to you guys. I remember when we started, one or two of you said, "Sir, so we're gonna have this class every Monday and every Friday at this time." And I remember answering yes. And I really didn't hear anything else. People don't complain. I don't know if you complain to yourselves or among your group or whatever it is, but I don't hear the complaints coming. But one of the things I can say to you, as I've said in meetings, this group that I have for integrated math, I'm gonna come out on a class. I'm a big one up for that. I have one problem with Uno, if I were to be very honest. Anybody can tell me the problem?
We're not talking.
Okay, thank you, Shanti. So let us continue. That's the only problem I have with the class. The only problem I have with the class. All right. So I'm still expecting big things from you guys. I'm still expecting big things. And I want you to speak up. Natty said, "Boy, sir, I like the maths." And she speak and she said, "Boy, sir, me don't understand what is happening. Sir, me lost." Make me tell Natty, say, "Natty B, you bother me too much." And guess what? Natty B will never hear that out of my mouth. I'd rather tell Natty B, "Natty, meet me into the breakout room." And me and her will go and have a conversation and whatever else. I said, "Natty, link me after class. But you need to talk up. That's your responsibility." All right. Let's go. So as I was saying, so your responsibility now is to either screenshot or to write your notes. Right? So you need to screenshot or to write your notes. It's very important. Okay. Let's go. All right. So is a little problem you have right to say no? Hold on, let me see if I can circumvent. All right. Can I move screens?
Yes, sir.
Yes, sir.
Yes, sir.
Scalar multiplication. A scalar quantity. Look at me. If I say 2 multiply by 1, 2, 4, -1, it means that this scalar quantity, the 2, is going to be distributed over each element in this matrix. Not just the 1 year, but the 1 year, the 1 year, and the 1 year. It is going to be distributed over each entry or element of the matrix. You can't stop it. You can't prevent it. It is going to be distributed throughout the matrix. So every element every entry in the matrix will be affected by it. So it's going to be 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, and 2 times -1 is -2. So that is going to be my matrix. Any question?
No, sir.
No, sir.
All right, good. Very nice. Let me give you one other, let me not even write it like that. And if I say to you, -1, 2, 0, -4, what will be the result? Tell me.
-1, -2, 0, +4.
Say it again.
Positive
Positive 1.
Positive
Positive
1,
-1,
-2,
-2,
0, and
0, and
+4.
+4.
Very good. Thank you. So +1, -2, 0, and +4. So just remember, if you wonder why it is that I said, excuse me again, because when you multiply two negative numbers, you get a positive number. All right. So whenever you're multiplying and the signs are the same, your result is positive. Once you're multiplying and the signs are different, the result will be negative. Negative sign supersedes the positive sign. Guess what? Scalar multiplication done. Not to be unmute and talk to teacher. Or you stay.
I don't understand.
You go through. Nice. Hey, Natty, boy, you sit on the front of the class and the more you move from where they here and come at the front. You know why? I'm going to move into one next one and more you sit that one here. All right? Very nice. And put on a piece of chicken leg, man. Come on. Come. All right, let's go. So we looked at matrix addition. We looked at matrix matrix subtraction. We look at the scalar multiplication. Now, guess what? When I'm multiplying the matrix, is a scalar quantity that I'm using to multiply the matrix. So it can be of any size. It can be anything. I'm just increasing that stuff. All right. So I'm increasing the first one by 2, and then I'm doing that one by -1. So yeah, that's all that there is to it. Now, let us talk about the boyfriend and girlfriend something again. And I hope I'm not on speaker and an appearance here and teacher talking about boyfriend and girlfriend because they may wonder, how can we send me pitney them go do Jesus? But anyhow, you can tell them to come and join here because they will need to know about husband and wife situation too. When we're doing other matrix multiplication, we have to talk about matrix compatibility. We have to talk about matrix compatibility, right? Because, as I said before, not to be, I could tell a youth, say, my youth, you can't buy my Gucci bag. So guess what? Keep walking. All right? Natty will say, sorry. So what do you have on paper? So why me have to go to school and go sit in an integrated math class on a Monday night, on a Friday night, and you're going to tell me, say, you're about your amigo? No, brethren, we can't say eye to eye. Go about the business. Right? Natty may see a farmer, and the farmer may not look clean and smell clean in the days, But when him come home, him take care of himself and him look good, and Natty B say, you are the husband. Because, and guess what? Natty B may still be working enough more money than him. But Natty B sees that he's a hard-working man. Him go out and him go plant him field and him reap and him sell him crop. When a crop time, him have money. When it's not crop time, money low. Natty say, no man, people like that I want, right? Compatibility. Now, sir, where are you going with this matrix compatibility and how does it relate to this something you're talking about? Watch me. A 2 by 2 matrix being multiplied by a 3 by 1 matrix is not matrix compatible because them two signs, numbers right here, so must be the same in order for me to talk about matrix compatibility. So you can't do this matrix multiplication. Not compatible. Not compatible. It's not compatible. All right. So What then, sir, if I
Sir,
multiply?
not all right, not all right. Go back over that, please.
Okay, so what I'm saying to you is, if I were to multiply a 2 by 2 matrix with a 3 by 1 matrix, I'm saying it's not compatible. Why, sir? Because you see the two numbers and beside a big multiplication sign, they are different. So when they're different, the matrix is not going to be compatible. Remember the question that Matthew asked? So we can add this size matrix with this size. There's going to be something that is left out. So I'm not going to be able to multiply it. So the same response I gave to Matthew is the same response I'll give to you when we're talking about matrix multiplication. One piece of it we'll be able to multiply, but it's not all of it we're able to multiply. The matrix can't work. The matrix selfish. The matrix say, sorry, at a 4 away in another matrix here. And if one I get, everybody forget. No, sorry. Just like when we look at number 1, with our 1, 2, 4, -1. The two outside say, I'm just going to multiply by the 1. And the 2 and the 4 and the -1 said, no. If it's just a 1 alone, the 1 will do it out. We have to also be a part of. All right. So when you're checking for matrix compatibility, you have to make sure that the number is what I'm saying. I am multiplying a 2 by 2 matrix by a 3 by 1 matrix. So I'm multiplying a 2 by 2 matrix with a 3 by 1 matrix. The big multiplication sign betwixt the two dimensions of the matrices we're talking about. If those numbers, as I indicated right there, are not the same, the matrix is not compatible. Is that compatible?
Yes, sir.
Yes, sir.
Yeah, man. How you know that, sir? See the two one them here are the same? Them here are the same. So you can do this matrix multiplication because the numbers beside the big multiplication sign they are the same. Now, so whenever they ask you to do a matrix multiplication, first check for matrix compatibility. So how we do that? Same way, let me do it. So they may not tell you that multiply this 2 by 2 matrix by a 3 by 1 matrix. They may give you the matrices. A is equals to bam, 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 bam. B is equals to bam, 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 because 3 rows and 1 column. So what you're going to write on is 2 by 2 times a 3 by 1. Oh, but this can't work. Not compatible, sir. Can't work. But the man them said to you, say a 3 by 1 multiplied by a 1 by 5. Yeah, man. Can't work. Can't work. Because the two numbers between that big multiplication sign are the same. All right. So that's what it is that we talk about for matrix compatibility. So the sign between the both must be the same. Are there any questions? Natty B, you see that now, honey?
Yes, sir.
All right. Can you all take the screen off for me? Take this information off for me? Take the information off for me, please, because I'm going to give you an example now of matrix multiplication. Let me know when you have done it. Don't let me sit down here and wait here.
Sir, I'm finished.
Finished. Nice. All right. I am going to touch on on something that I'm going to tell you straight up. I want you to look at what I'm doing. So it will make it sound like it's hard, so no, it's not hard. But I just want you to pay attention. So before I do my matrix multiplication, I'm checking for compatibility. Checking for compatibility. The first matrix is a what kind of matrix?
2 by 2
2 by
square.
2.
And it's being multiplied by a?
2 by 2.
2
2
by
by
2.
2.
Okay, very good. So that's the point I'm making. So I know that my matrices are compatible. Look. Row times columns. Can you repeat that for me, please?
Row times
Row
column.
times columns.
Column.
Very good. It is a row, the first row multiplied by the columns. You see, when we finish that, the second row is going to be used to multiply the same two columns before. Let's just get personal. When I was doing this in little school, I have to practice enough. Because sometimes I get the question right and sometimes I get the question wrong because I wasn't consistent with the pattern until one day I just wake up and I start do it properly. It is your row, your first row, times the two columns. Then the second row times the same two columns. Don't blink. Watch this. 6 times 2 is going to be 12, don't it?
Yes, sir.
Yes, sir.
Oh dear, sorry. I don't want that. So 6 times 2 is 12. So how you get that 6 times 2? This 6 times this 2 is 12. And then I'm going to say plus -1 times 3 is -3. So you can do that one more time for me, please? My pleasure. This 6 times this 2 gives me this 12, plus -1 times 3 give me -3. Yes, please.
I'm not seeing your pointer.
You're not seeing my pointer. Okay. Here. Trouble. Trouble. Okay, found it. Okay. That 12, that 6 times this 2 gives me this 12. Can you see that?
Yes, sir.
Yes, sir.
That -1 times this 3 gives me this -3. Can you see that?
Yes, sir.
So that's the pattern. So the pattern is going to be 6 times 2 gives me 12. -1 times 3 gives me -3. All right, very important. Now, similarly, 6 times 2, the other 2 over this other side, is going to give me 12. It's going to give me 12. And then this -1 times the -1 there is going to give me the -1. -1 times the +1, sorry. So look at what is happening. 6 times 2 gives me 12. -1 times this 1 is going to give me -1. It's very important. All right? Watch me now. I'm finished with that. Four times 2 gives me 8. Plus 5 times 3 gives me 15. This 4 times this 2 gives me 8. 5 times 3 gives me 15. 4 times the other 2 gives me 8. And 5 times 1 gives me 5. So what do we have here now? 12 minus 3 is 9. 12 minus 1 is 11. 8 plus 15 is 23. And 8 plus 5 is 13. What size matrix do I now have?
2 by
A 2 by 2,
2.
no?
By
All right.
two.
So your answer is going to be the other values there. Your answer is going to be the other values there. Let me go back to this. So this one is not compatible. This one is. But what will I get as a result? I'll get a 3 by 5 matrix. See here, this 5 and this 3. So because these two numbers are the same, my result is going to be a 3 by 5 matrix. So when I multiply a 3 by 1 matrix to a 1 by 5 matrix, my result is going to be a 3 by 5 matrix. The other pair of numbers will tell you what my answer is going to be. The size, the dimension of the matrix is going to be. The dimension of the matrix is going to be. All right. So I know that I was going to have a 2 by 2 matrix. So that is my 2 by 2. That is my 2 by 2 matrix. Really and truly, this, what I'm doing here is just preparation for what is to come. I know I will be able to talk to you about some other forms of the matrices, but I just want to get these groundwork, foundational pieces out of the way. So what I'm going to do is to give you a do now. Just to see how well you're going to do it. I'll give you a couple of minutes. Start for me, please. Get an answer?
Yes, sir.
Yes,
What's the
sir.
answer?
Yes,
What's
sir.
the answer? What's the answer? What answer you got?
Sir, negative 1, 13, negative 4, 42.
Okay.
I got that, sir.
Okay. Bueno.
Sir, I don't get
So, I don't understand why why didn't you get it? And you're laughing at yourself? All right, come, let's go. Let's go. Let's go. Ta-dum, 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 ta-dum. So remember, row times your columns. 1 times negative 1 is negative 1, plus 2 times 0 is 0. Then the same 1 times the 3 is going to be 3. But 2 times this 5 is going to give me 10. Finish with the first row. See, the first row gives me up here. The first row gave me up here. The second row will give me the last two rows, the last of. 4 times negative 1 is negative 4. 6 times 0 is 0. 4 times 3 is 12. And 6 times 5 is 30. So that gives me negative 1, 13, negative 4, and 42. Congratulations, very nice. Look at that and tell me if you see what is happening now.
Yes, sir.
I'm going to give you one more for the road. One more for the road. That's it.
Finished, sir.
Sir?
Sir, audio give problem.
Have you gotten an answer?
Yes, sir.
Yes, sir.
Yes, sir.
What's the answer?
618, 412, 26.
Yes, sir. That's what I have.
That's what I have to.
Say it again. Say it one more time for me.
618, 412, 26.
Okay, okay, okay. Very nice. Anybody got anything different? He went across 618, 412, 26. Anybody got anything different?
No, sir.
No, sir.
3 times 2. Okay, so it's a 3 by 1 being multiplied by a 1 by 2. So I'm supposed to be getting a 3 by 2 matrix. That looks like a 5. I'm supposed to be getting a 3 by 2 matrix. Three times 2 is 6. 3 times 6 is 18. 2 times 2 is 4. 2 times 6 is 12. 1 times 2 is 2. 1 times 6 is 6. And that's what it is. That's what it is. And that takes us into Ouch, copper 20, Lord Jesus, help me. That takes us into the end of this matrix multiplication. This is revisioning and not spending the whole class time on this. Very good for those of you who got it. Excellent. Excellent. May I take off the screen, please?
Yes, sir.
Yes, sir.
Yes, sir.
Then now, what we're going to look at is the equality of matrices. Right? So we're looking at the equality of matrices. So when we look at the equality of matrices, we look at the corresponding elements or entries. We look at the corresponding elements or entries across the equality sign or the equal sign. Right? Across the equal sign. They also must have the same dimension or order, size. These are terms that we use interchangeably. I'm just going to state two examples for argument's sake. I'm going to state one, and then I'll have you do the other one for me, and then we'll move into the other aspect of what it is that I want to look at. What time is it? 7:21? All right, good job. So if I say to you for argument's sake, P227, and that is equals to -1227. What's the value of P?
-1.
-1.
Excellent. Sir, what am I just -1? I don't get -1, sir. Remember I said to you, the equality of matrices, they're supposed to be each element is equal across the equal sign. It's supposed to be the same across the equal sign. You know, there's this 2, is this 2, and this 7 is this 7, and this 2 is this 2. So this P has to be -1 in order for these matrices to be equal. So this P has to be -1 in order for that matrix or the matrices to be equal. All right. So that's one. This is your do now because it's not hard. I mean, it really isn't hard. Ouch. I'm having a difficulty writing. I don't know what it is that I did my thing. Oh, maybe I'm texting too much. All right. G minus 2, 2, F over 2, X squared is equals to 5, 2, 2, 4. Do that evaluation. Evaluate G, F, and X. Three minutes. What's the value of G?
7.
7.
What's the value of
Seven.
X?
Two.
What's the value of X?
Oh, 4.
4.
The F is 4.
4.
F is 4. What's the value of X?
2.
2.
2, sir.
All right.
Oh.
Set B.
What is the value of X?
2, sir.
Two,
2.
sir.
Two, sir.
What's the value of X?
16.
What's the value of X?
Sir, 2.
Sir, 2.
Sir, 2.
What's the value of X?
The 16.
No. What's the value of X?
2.
What's the value of X?
Square root of 4.
And what is that value?
2.
What's the value of X?
2.
What is the value of X?
Sir, 2 squared.
So G is 7 and F as in Frank is 4. What do I say about X?
So what did you say a while ago, sir?
G is 7. F is 4. What is X?
Sir, not 2 are the answer.
Not 2, sir.
Sir, 2 squared.
Sir, it's 2.
2, sir.
Sir, are you hearing us say 2 or are you hearing us saying something else?
I'm hearing you say Tania 2. I hear Matthew say 2, and I hear everybody say 2.
Sir, 6.
Sir, so
Sir, so not 2 are the answer.
Natty D. What's the value? What? Give me X.
Sir, I got 2. 2.
Sir, what about
sir,
6?
so if it's not 2, then is what?
All right, I'm going to give you 3 more chances. What's the value of X?
Sir, apple.
I get 2 and I'm sticking to the 2.
Sir, it's 2.
Sir, me
Sir,
too.
2
I 2
but
my
get
guess.
to know and
Sir, are you have the
change
wrong
it, sir.
Will you say it?
Sir, I got apple.
You got option.
Sir,
Okay.
you don't want to take the 2, so we'll give you something else. I got apple for the answer.
Okay.
Sir, 8.
Cree, here? Cree. Come in, no way gone so far for Cree.
Half.
No. Terry, what do you give for the answer?
2, sir.
Taylor person. Taylor, what do you give for the answer?
2.
Okay. Is there anybody else? Well, let me not ask that question like that.
Sir, 4.
Sir,
Let me-
I tell you, say, and 2 are the answer.
Sir,
if I'm going to tell that to is,
answer the
if I'm going to tell that to is that.
Sir, you're
Alright.
joking, right?
I am not fully joking. I'm actually kind of serious.
Sir, what I
Jay,
think again?
Jamie, serious. No, okay. So you're not changing your mind, but I am going to. And look how you feel shame after me tell you. Me none of feel shame.
1.
Then sir, X out. Tell us, sir,
Sir,
how we
2
know.
squared.
Sir, 2 squared and 4.
Sir,
Plus
2.
or minus 2, plus or minus 2, plus or minus 2, plus or minus 2.
Plus.
Positive.
Positive 2.
Or negative 2.
Eh?
Oh, yes.
Yeah, but cause negative times negative, you're gonna get positive.
Sir,
You know what if you,
seriously?
like telling you? Seriously. I mean, if you see my face and you not even a smile upon it. Seriously. Yeah, man. So you have to put the negative 2 also. So I had to be very careful how I word my stuff because I wanted to see if somebody would pick up, but none of you were able to pick up.
Yeah, so we put positive 2 on the exam, we're going to lose mark.
You're not going to get the full marks because there's another answer that was missing. But talk to me though. Can you agree that negative 2 is also a possible solution?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, man.
Yes, sir.
Because negative 2 squares is also 4. So a question like this could be like 4 marks, 2 marks for the plus or minus 2, 1 mark each for the F and 1 for the G. So many of you would have gotten 3 out of 4 marks. Many of you would have gotten. You have to remember when we take the square root of a number, it's a positive root as well as a negative root. Please be very mindful on. When I thought of the question, I wrote the question. And I was like, "But why am I giving them this?" I said, "No, give it to them because it is possible." So yes, just remember, guys, I'm using the teachable moment out of this lesson to say that yes, I could have the positive root as well as for the negative root. The positive root as for the negative root. Very important. Yes, please.
So I just want to add, you just find some random number which I get the result back 5224.
No, you go say G. Oh, can I? Listen to me. You're not going to supper tonight, you know. Remember, they're supposed to be equal, right?
Yes, sir.
So we have they're supposed to be equal. So let me put that in blue. So I'm going to have G minus 2 must be equal to 5 because they're in the same position. So G is going to be equal to 5 minus 5 plus 2. So G is equal to 7. And the F over 2 must be equals to 2. And I can write it as 2 over 1. When I have 2 fractions separated by the equal sign, I always cross multiply. Every single time, barring none. So when I cross multiply, F times 1 is F. And 2 times 2 is 4. So F is going to be equal to 4. And then now, I'm going to have X squared is equals to 4. When I take the square root of those, X is going to be equals to plus or minus dos. Very important. You have to take the positive root as well as the negative root. Because if you check it, 2 squares is 4. So is negative 2 squares. When you multiply negative 2 by negative 2, you're going to get positive 4. Talk truth.
Yes, sir.
So you have to be very careful. All right. I want you to capture this for me, please. I want you to capture. I must have a. Yes, please.
So I can go over the x square equation is
Okay, so the x squared is equals to 4. I need to find the value of x. I'm going to take the square root of both sides. So when I take the square root of x squared, I'm going to get x. But when I take the square root of 4, I'm going to get positive 2 and negative 2. The square root of a number results in the negative root and the positive root of it. So you're going to have the -2, and +2. So the square root of 100 is -10 and +10. Why, sir? Because 10 times 10 is 100. So is 10. -10 times -10. Sir, what then is the square root of 25? Plus or minus 5. Why, sir? -5 times -5 is equal to +25, and 5 times 5 is equal to 25, +25. So you have to take into consideration the negative root as well as for the positive root. Now it's different if the question says to you that the roots are positive. If them say the roots are positive, you exclude the negative one. You're going to exclude the negative one. So, very important. Any questions? We're good?
Yes, sir.
Yes, sir.
All right. So we're going to make sure you capture somehow, either you write or you screenshot. It's important that you capture. This goes in tandem with the recordings, and you should be fine. You should be fine.
So you post the ones from last week?
Long time. A long time. They came in very late. They were slow in coming, some of them. So by the time I'm there waiting on it, never came. So I moved on to something else and totally forgot. But they're all there now. Thanks for the reminder. Alrighty. So now the conversation continues. The conversation continues. And it continues with us having a little chit chat about elements of a matrix. The truth is, for this course, they can go up to the solution of a 3x3 matrix using a methodology that we call Kramer's. The syllabus says we can also use any other method is accepted, but I will teach you Kramer's. I'm not going to teach you any other method. I'm going to teach you Kramer's. Kramer's is the bomb, the big man. Not only that, because sometimes the question may ask you to calculate the determinants, and that's all you're doing for Kramer's. When they ask you to do Kramer's, all you're doing is calculating determinants. So Kramer's is really not difficult. Once you know how to calculate the determinants, you're good to go. So without any further ado, because what I want to do, I have almost, what time is it? 40 minutes left. What I want to do is to get to a solution of one of these questions so I can leave you over the weekend to do some work. Incidentally, what you wouldn't recognize because you're maybe not looking at the syllabus, I think you have like 4 or 5 areas on the syllabus, and I've gone through quite a bit already, and this is just the major part that is left. When I finish this part, I'm finished with this unit. But this part has some intricacies that we need to talk about. Don't worry about it. I have all the answers for you to present it so we can talk, and then subsequently we can get this out of the way. Ready, steady, go. So as I said before, we're going to be focusing somewhat on a 3x3 matrix, and I am going to be writing this for argument's sake. A11, A12, A13, A14. Oh Lord, you know when you're in a mode, A14, it's supposed to be A21, A22, A23, A31, A32, A33. Okay, so we call the rows first, followed by the columns. So when we are looking at our stuff, the rows are called first and then the columns. So A11, as we figured out before, indicates that the element is in the first row and the first column. A22 indicates that the element is in the second row and the second column. And A32 is indicating the third row and the second column. So just remember, the A11, A12, A13, A21, A22, A23, A31, A32, A33 is just showing you the position of the entries, the elements in the matrix. The position of the elements in the matrix is not one where you can just nilly-willy go and just change it. I don't like how this one fit here, so I'm going to move it. It doesn't work like that. They have a fixed location. A fixed location. All right. Now, in teaching you Kramers, I'm going to speak of the ith row and the jth column. I'm going to be speaking of the ith row, and the jth column. So we are talking about, yeah, I row, j column, right? So when we're referring to a 3x3 matrix using Kramers, that's what we talk about, the ith row and the jth column, right? And the method is just used to solve a system of linear equations. So really and truly is a simultaneous equation you can solve, but we use the matrices to solve the simultaneous equation. And in particular, it's a 3x3 linear set of linear equations. So Kramers is really used to solve a 3x3 system of linear equations. Sir, what we're going to do? So for example, the man can tell us, say, 3 patties, 1 cocoa bread, and a juice cost X amount of money. 6 patties and 3 cocoa bread and 5 juices cost an X amount of money. The other one may say 1 patty, 1 cocoa bread, and a dozen juice will cost another amount of money. The question can ask you, calculate the value for 1 patty, 1 cocoa bread, and a juice. All right. So they can give you real life questions for you to generate the solutions out of it. So it really isn't difficult, but there are several things that must be done, and I want you to pay attention. Even if we can't fulfill the solution to the question, at least I need to teach you how to calculate the determinant of a 3x3 matrix tonight. So let's go. So what we're doing technically is talk about the -1 to the I plus j. Lord Jesus, sir. Don't worry about it. You will see how nice it comes out. Ith row, jth column. Ith row, jth column. Ith row, jth column. What is 1 plus 1? What is, oh, you're not seeing my spotlight. What is 1 plus 1? It's not right. What is -1?
Sir.
What is -1 raised to the second power?
+1.
+1.
Yeah, 41.
What is 1 plus 2?
3.
3.
What is negative 1 raised to the third power?
Negative 1.
Negative 1.
What is 1 plus 3?
4.
What is negative 1 raised to the fourth power?
Positive 1.
1.
Positive 1.
What is 2 plus 1?
3.
What is negative 1 raised to 3?
Negative 1.
I'm doing the last one. What is 2 plus 2?
4.
What is
4.
negative 1 raised to the fourth power?
Positive 1.
Positive 1.
So what do you think this one's supposed to be? The next one.
Negative.
And then the other one?
Positive.
Then?
Negative.
Then?
Positive.
Positive.
All right, so that's what I call my array of signs. The array of signs. Plus, minus, plus, minus, plus, minus, plus. Very important. Plus, minus, plus, minus, plus, minus, plus. Very important. Now, how important this is? It is like your jerk seasoning in doing jerk chicken. Is like the oxtail gravy in the oxtail. It's like a strawberry daiquiri with something inside of it. Very important. You can't solve a Cramer's question without having your array of signs, plus, minus, plus, minus, plus, minus, plus. Then, sir, I have to go remember the I through on the jth column and do the calculation every time. No, I am only showing you so that you see it one time, you know where it come from. No, so all you have to do now is just go and apply it every time. So now you just go and apply it. Plus, minus, plus, minus, plus, minus, plus. 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 The signs alternate. The signs alternate. Start with a plus, end with a plus. Sir, why we never start with a minus? Because the first row, first column, when I add my ith row and my jth column position, I get 1 plus 1 is 2. And when I square, when I raise a negative number to an even power, it is always positive. When I raise a negative number to an odd power, it is negative. When I raise a negative number to an odd power, the result is negative. When I raise a negative number to an even power, the result is positive. You notice I never write a plus 1. I hear odd numbers, sir, plus 1, minus 1, minus 1, plus 1, minus 1, plus 1, minus 1. That's okay, fine. Not interested in the ones. They're important, yeah. But what I want is just an array of signs. Plus, minus, plus, minus, plus, minus, plus. Okay, sir. I want to see how it is that we're going to apply this plus, minus, plus, minus, plus, minus, plus. Soon show you. So what I want to do is, I just want to show you how to, not show, I want to remind you how to calculate the determinant of a 2 by 2 matrix. And then we're going to the determinant of a 3 by 3. So why? I have to pause and show you the 2 by 2 matrix because we are going to use the 2 by 2 matrix in order to solve or to calculate the determinant of the 3 by 3 matrix. So I'm just going to refresh your memory. So I'm doing a recall. So I'm not teaching another topic now. I'm just doing a recall so it is I can know what is happening. So I'm going to ask you to save this thing for me, please. I'm moving into another slide. And let me know when you have saved it or you would have written it off. Capture it somehow, students, please. All right, so now when I get my plus minus plus minus plus minus plus, I am now using it to calculate the determinant of the 3 by 3 matrix. I'm going to use it to calculate the determinant of the 3 by 3 matrix. Now, to calculate the determinant of the 3 by 3 matrix, I must have this array of signs: plus minus plus minus plus minus plus, plus minus plus minus plus minus plus, plus minus plus minus plus minus plus. Very important. All right. So moving, I need to, as I recall, we need to look at the determinant of a 2 by 2 matrix. As I recall, we need to look at the determinant of a 2 by 2 matrix. Watch me. A, B, C, D. And of course, that's a 2 by 2 square matrix. Hold on a minute, please. So it's a 2 by 2 matrix. Now watch me carefully. When I'm calculating the determinant of this matrix, I'm going to be using the leading diagonal minus the other diagonal. It is a leading diagonal minus the other diagonal. So it's going to be A times D minus B times C every single time. It is nothing else.
What?
Yeah.
So
same thing.
Because when we just did the other something, where did I go? Not that way. We never did I go that way here.
You notice I said recall. I cannot press pause on what we were doing because I need to go back to something that you should know. So I'm showing you how to calculate the determinant of a 2 by 2 matrix. So this is something different. So let me go again. To calculate the determinant of a 2 by 2 matrix, I'm calculating the determinant of a 2 by 2 matrix. Now remember, you can't divide matrices. You can't divide matrices. All right? So when you're solving a system of linear equations using the matrix method, you have to find the determinant. Then you can find the inverse, the adjoint. Remember, when you're doing the 2 by 2 matrix, you find the determinant, then you find the adjoint, and the determinant times the adjoint give you the inverse, and you multiply the inverse of the matrix by the other stuff, by the matrix itself. But how you multiply the matrix, it has to be in front of. Anybody remember that?
Yes, sir.
Yeah, man. So now for the 3 by 3 matrix, when we solve the 3 by 3 matrices, we have to go and do or determinants. It's only determinants that we're calculating, and then we're going to be manipulating the determinants in order to get our values of the 3 unknowns in the question, right? So remember, Kramers speak about the 3 by 3 system of linear equations. 3 by 3 system of linear equations. So what I'm saying to you is, once I'm calculating the determinant of a 2 by 2 matrix, it's going to be the leading diagonal minus the other diagonal. The leading diagonal minus the other diagonal. So what are you saying? It's going to be A times D minus B times C every single time. So for example, if I give it A to be 2348, 2348. And I asked you to calculate the determinant of A. And so what we use, those two, the square bracket right there. If I'm calculating the determinant or two strokes, or whatever you want to call it, I'm calculating the determinant of A, it's going to be 2 times 8 minus 3 times 4. Then, so how the array of signs come in play? The array of signs not touch this yet. Because in calculating the determinant of a 3 by 3 matrix, I must refresh my memory how to calculate the determinant of a 2 by 2 matrix. So now that's why I press pause to go through the determinant of a 2 by 2 matrix. I must calculate the determinant of a 2 by 2 in order to calculate the determinant of a 3 by 3. And there's something else that I don't want to tell you yet, but I want you to discover it on your own. All right? So 2 times 8 is going to be 16, and 3 times 4 is going to be 12. So the determinant is going to be equals to 4. The determinant is going to be equals to 4. Any questions?
No, sir.
No, sir.
Okay, it's very important. Now, for those of you who find it so difficult to press unmute to speak, as a matter of fact, let me teach you something using Zoom. You don't have to press the unmute button. I want all of you to try this for me. All of you mute your mics. And then I'm going to ask you to just press the space bar. Those of you who are using a computer, press the space bar and talk to me a little bit. Just press the space bar.
Yeah, that's what I do.
Right. So you temporarily unmute when you press your space bar. So when you press your space bar, you're temporarily unmuting. So you don't have to look for the unmute button to unmute. If you want to say a quick word, you just press the space bar. That's only if you're using a computer, right? So if you're using a computer, you just press the space bar to temporarily unmute, say what you need to say quickly, and then you release the space bar and you come back to your mute. Right? There are times when I'm in a class and I'm trying to, a student asks a question, I'm sitting here and I'm hearing, I was like, okay, where's the unmute button? I can't find it. Press the space bar. Yeah, man, well gone. Sure, no problem. Release the space bar, I've gone back to mute. All right, and I'll give you a little one or two more tips as we go along. All right, but students, I forgot to talk to teacher, at some point in time, and don't let it be too late, Don't let it be too late. All right, let's go. Is it because there's nothing into it? I'm going to give you one to do for me. As I do know, because I'm not spending, this is not what I'm here to teach. This is a recall. Do know. I want you to evaluate the determinant of this matrix for me. 1, 3, 5, 15. And tell me your answer.
0.
0, very good.
0.
No, excellent. Excellent. 1 times 15 minus 3 times 5. So it'll be equals to 15 minus 15, which is equals to 0. What do you know about that? What is so specific about when the determinant is equals to 0?
Sir, and I said, oh, remember.
It is called a singular. It's called a singular matrix. It's called a singular matrix. Yeah, it's called a singular matrix. Now, why is this important for me to talk about? It's important because singular matrices have no inverses. So you cannot find the inverse of a matrix that is singular. So when it's equal to 0, you have a singular matrix, and you cannot find the inverse of a singular matrix. All right, that's it. I'm moving back now to my 3 by 3. That's how we calculate the determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix is going to be the leading diagonal minus the other diagonal. It's going to be the leading diagonal minus the other diagonal. A times D minus B times C. A minus D times minus B times C. It's the leading diagonal minus the other diagonal. To calculate the determinant of a 3 by 3 matrix, I want you to sit up. Pay attention. You shall see this only once. And then you're going to be required to do some work on your own for me. to calculate the determinant of a 2 by 2 matrix, it's the leading diagonal minus the other diagonal. It is a leading diagonal minus the other diagonal. A times D minus B times C. Capture this screen for me, please. I need to move into another screen. Okay. A, B, C, D, E, F, G, H, I. Stop right there. All right. Anybody remember our array of signs?
Yes, sir.
Yes, sir.
Hello?
Still
Yes,
here,
sir.
sir. Your screen is gone.
Rockstone. And that's why sometimes I'm afraid of using this device, you know. Oh, I know what is happening. My thing needs to charge. Oh, so crap. Let me see how much time, how much power I have left. I have 5. Okay. All right, let me just show you this. All right. I apologize. I would have now lost my A, B, C, D, E, F, G, H, I. Let me go back quickly. Nope. A, B, C, D, E, F, G, H, I. No, I was asking a question before we got interrupted. If you remember the array of signs, you remember where we start? How we started?
Positive.
Plus, minus,
Positive,
plus.
then negative, then positive.
You notice you don't have 2 of the same signs beside each other, but you started a plus and enter plus. Plus, minus, plus, minus, plus, minus, plus. Now, when you calculate the determinant, that is easy. I mean, that is going to be required. So that's what the array of signs will do. So look at what is happening now. Watch me. Watch me. I'm going to say A. We calculated the determinant, you know. This is calculating the determinant of a 3 by 3 matrix. Watch me. A. A. You know, it's only one A on the board, so you know what me I talk about. A times E, F, H, I. Sorry, I forgot to talk to me and tell me how you get it. Watch me. I'm talking about A. Anywhere, any column that A falls into, any row that A falls into, I am taking it out. Can you see that?
Yes,
Yes,
sir.
Yes, sir.
What is
sir.
left? No, E, F, H, I leave.
Yes,
Yes,
sir.
sir.
All right. So I write that. All right. Watch me now. And then I am going across. I'm going across this row. I'm going across my row. I'm going across. Hey, something, leave me alone now. I'm going across that row there. Huh? So now I'm going to have minus b. Oh, so that's where the array of signs come in, sir. Yes, the array of signs coming in to what I call my cofactor. So the array of sign only affect my cofactor. It don't affect anything else. All right, but watch this trick now, and I want you to see it. Watch this trick. Anywhere the b falls into, I am going to take out that column as well as the row that b falls into. What matrix is left?
DFGI.
DFGI. Everybody see that?
Yes, sir.
All
Yes,
right.
sir.
Yes, sir.
Good. And then now I'm going to talk about my plus C. Sorry, I don't have any space over there, so I'm just going to put it on this side here. Plus C. And plus C is anywhere my C appears, I'm taking it out in the column and I'm taking it out into the row. What matrix is left?
DEGA.
And that's it. So you notice for my 3x3 matrix, I have to reduce my 3x3 matrix into 3 2x2 matrices.
Yes, sir.
Yes,
All
sir.
right. And then now you know how to calculate that, because this is going to be A times EI minus FH. Talk truth.
Yes, sir.
Yes, sir.
Minus B times DI minus, oh crap, I don't have enough space on that side. You may seem as if I have enough space there, but my writing device is saying that I don't have. So I'm going to put the minus sign there. And then I'm going to put back my B now, minus B times DI minus FG. Don't. And then plus C times DH minus EG. Sir, I'm not like, sir, appear A, B, C, D, E, F, G. Sir, I'm not supposed to be with numbers. I don't understand what go on. Capture that for me, please. I want you to take that off because it's going to be very important in us looking at an example. Very, very important in us looking at an example. Oh, Lord, help me. My tablet is going to die at some point in time soon. I only have a little bit of percent on it. So I want you to take up that for me quickly. And then I may have to project from the computer whiteboard instead of using the tablet. Yeah, so I'm gonna have to do that from the computer whiteboard. Let me know when you have it off, please.
Oops. Sorry, yes.
All right, good. Okay. And then now you're going to calculate, you're going to evaluate for me the determinant of the 2x2 matrix. I'm not going to show you, I'll show you just now how we say EI minus FH. You know how to evaluate the determinant of a 2x2 matrix because we just did that. So that's what is going to be required of us. That's what is going to be required of us. And then now I want you to take that down on paper, side of you, because we're going to do a real question now on that. Very important. Very, very important. All right. Very, very important. Okay. So that's going to be DH minus EG All right. So take that off for me, please. Let me save that in case I need to come back to it. I have it. I'm going to stop share from this device. I'm going to, oh Lord, I need to connect to my other device before I leave this one, because this one is going to, oh, so I need to connect this one. You may hear a loud noise for a brief moment. Are you still with me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, good. So I have just successfully parked this my two writing devices that I was using. You can go over there. So, oh, not quite. We need another writing device to plug into the computer now. Hey, sit on. Wrong with my friend. Sure. Right. So, sharing my whiteboard, if I can find it. I'm sharing my whiteboard. And I want us to together to work out the determinant of this 3x3 matrix. That's the only one I can use this one. This one's enough. Let me see if I can. All right, let me see if I can use this one here. Yep. Okay, so if I give you, say, 2, 3, 5, 1, 2. 1, 4, 2, 7, 6, 9. This whenever I have those square brackets, it means that I'm calculating the determinant. Once I have those square brackets, it means that I'm calculating the determinant. All right? Watch me now. Watch me. Once I have those square brackets there, it means that I'm calculating the determinant. So sometimes they may say evaluate and just draw that sum. And you have to know what I'm talking about. Evaluate, you draw that. I know them at all about. All right. Then now I'm going to put in my plus, minus, plus. Okay, my life problems again. I'm supposed to know that, you know. Oh, come on. Minus, plus, minus, plus, minus. Hold on there. Hold on. Plus. All right. Now, so remember, you're going to have your array of signs. We have our array of signs, plus, minus, plus, minus, plus. Hold on a minute, please. All right, so let us see how best now we can do the calculation. Let us see how best we can do the calculation. So watch what Sir did a while ago. What Sir did a while ago was to say 2. What is a matrix here that we're going to have a 2? Tell me the matrix.
4, 2, 6,
4, 2, 6, 9.
Very good. 4, 2, 6, 9. And then which number comes next? What's the cofactor for that one?
-3.
-3. Very good. -3. And then what's the matrix there?
1, 2, 7, 9.
1, 2, 7, 9. No, me really proud of you, you know. But you know, concerned about the others. Next, other cofactor is
+5.
+5.
very good. Oh, come on. And what's the matrix for that one?
1, 4, 7, 6.
1, 4, 7, 6. I'm pressing pause. Is there somebody in the class that don't have a clue who got the 4269, the 1279, and the 1476? I mean, I just showed you, yeah. But am I to understand? Am I to feel like a very good teacher that I spoke with such clarity a while ago that I presented the determinant of a 3x3 matrix, and you guys understand the first go that there's no question from not one somebody? Very nice, Mr. Shand. I feel encouraged. I feel very encouraged, and I will continue working to speak with clarity. He said, those of you who not understand and you know yourself and you not talk to me, you're gonna feel it. Let's go. So now what Sir says, we calculate the determinant of the 2x2 matrix C. So this is why Sir had to pause a while ago and show you the determinant of the 2x2 matrix. What is 4 times 9 is?
36.
Minus 6 times 2 is 12. Minus 3. What's the calculation there? Evaluate the determinant of that for me, please. It's going to be what minus what?
9 minus 14.
Very good. 9 minus 14. And then this is plus 5. And this is going to be 6 minus 28.
Yes, sir.
Yes, sir.
And this is going to be now 2. What is 36 minus 12?
24.
What is 9 minus 14?
-5.
And 6 minus 28?
-22.
I'm sure I am much better than this. Oh, Lord. All right. And it's because my tablet has died, you know, irresponsible of me. Jesus. All right, so let's go. So 2 times 24 is?
48.
48.
And negative 3 times negative 5 is?
15.
15.
Negative 15.
The positive 15.
No, 15. 15.
And what is 22, negative 22 times 5?
Negative 110.
And 48 plus 15 is going to be 63. Yeah, no?
Yes, sir. 63.
63 minus 110 is how much?
Minus 47.
Negative 47.
And sometimes we use a triangle here to denote determinant, right? So the determinant of this 3 by 3 matrix is going to be negative 47. And that's what we do to get our answer, negative 47. We're going to take 5 minutes. I won't even give you any as I do now in class. I'll give you those for homework. I want you to take 5 minutes. We have 5 minutes left. Let us use those 5 minutes to talk through what it is that we did. So sir just made up a question a while ago. 2, 3, 5, 1, 4, 2, 1, 6, 9, 7, 6, 9. And sir says, evaluate the determinant. Now remember, when you have your matrix in a square form like that, it means that you're calculating the determinant. It's not curved brackets. Square brackets, straight lines. There's no curve at all in it. Straight lines on either side. It looks like the absolute value sign, right? When we have it like that, it means that we're supposed to be calculating the determinant of the matrix. Now, why did sir go through the determinant of a 2 by 2 matrix again with you? It is as a recall. Just to refresh your memory from CXC, from CSEC, what it is that we would have done for the calculation of the determinant of a 2 by 2 matrix. So calculating the determinant of a 2 by 2 matrix, we always say the leading diagonal minus the other diagonal. So it's going to be A times D minus B times C. Sir, I now see why this was important for you to do the recall, because in calculating the determinant, so I recognize that he ended up calculating the determinant of 3 2 by 2 matrices. Very good if you recognize that. What you also need to recognize is when I calculating the determinant of a 3 by 3 matrix, I have to first reduce the matrix. And I'm reducing the matrix into a series of 2 by 2 matrices. So I can't just go ahead and just calculate the determinant of a 3 by 3 matrix as it is so. It no work so. I have to first go and reduce the matrix into several 2 by 2 matrices. Several 2 by 2 matrices. There's a method to our madness because we have to use the array of signs. The array of signs will tell us what sign goes to the cofactor. The array of signs only affects the cofactor. It does not affect my 2 by 2 matrices. The array of signs only affect the cofactor. They not touch the 2 by 2 matrices. Can't touch this. Only the cofactor. So you will see that I can go using any row or any column. When I'm teaching the topic, I like to first go with the first row until we develop our understanding of the question. Then we can move to any column or any row. You can't go along a diagonal. You can only go along a row. So if I wanted, I could use my cofactors as 2, 1, and 7, or 7, 6, and 9, or 3, 4, and 6, 1, 4, 2, 5, 2, 9. All right, I can use either any row, any column. I can't go along the diagonal. So there's no way I can use 2, 4, and 9 along the diagonal. That don't work. All right. So, but for now, in your spare time, you can try for homework, going across, using other rows or columns to see if you end up getting a negative 47. Since we use the first row, and that's going to be your homework. So since you use the first row for your homework, what I want you to do is to go ahead now and try using the second row, the third row, then the first, second, and third column, just to get your practice to see if you end up with a negative 47. If you don't end up with a negative 47 for all of them, it means that something go wrong, or it means that this calculation that we did together is incorrect. So, having gotten your 3 2 by 2 matrices, and we're putting the cofactor, remember, The plus minus only affect the cofactors, all right, not the matrix. Then you are just going to calculate the determinant of the 2 by 2 matrices. You evaluate that, 36 minus 12, you evaluate it to be 24. Then you multiply another cofactor by the determinant. You multiply the cofactor -3 by the determinant, which is -5. You multiply the other cofactor 5 by the determinant, which is -22. And when you do that, you're going to end up with 48 plus 15 minus 110, and you end up with your -47. It is not difficult. It will take a lot of practice. Hear me out. Monday, God's willing, Him sparing our lives, we want everybody come to class, a shot after all the cylinders. We don't want one cylinder work. We want the whole 6 cylinders step on fire. Have yourselves a wonderful rest of the night, and thanks for coming out to class.
You too, sir.
Bye, sir. Same to you.
Bye, sir. Bye.
Bye, sir.
Bye-bye.